You may have heard of virtual reality, or VR, where a person is placed in a simulated environment through the use of things like goggles with monitors in them and joysticks or the like to interact with a computer-rendered world, a virtual reality. There's also augmented reality, or AR, where the user can still see the environment around them, but something's added on. In this case, there's a classroom, but by holding up their phone, they can see things like Yoda and a dinosaur, Bugs Bunny, Tasmanian Devil. This is augmenting their reality. They can still see the reality around them, but they can also see cartoon characters. Now, how would we go about doing something like this? Well, we could begin by taking some pre-recorded video feeds. We could also have a 3D model of something like Yoda in the previous example, but we'll just make our own model with these video feeds. We'll transform these pre-recorded videos so that they take the shape of a cube. Once we have that cube, we could take a feed of the actual world, such as a beach, by using our phone or a tablet or really anything with a camera and having that placed in the background with our cube as an overlay. Now we'd want to interact with the world in some way so we don't just have a static image. One way to do this is to program it so that it understands the world around it. Now in this case, I simply have it interacting somewhat loosely with the ground plane where it hits it and then it's done. But there are other ways that you can interact with the real world by using things like tracking. Now, a famous example of using tracking with an overlaid video would be a lightsaber from Star Wars. Now, originally, when the lightsaber was being created, they had to go over frame by frame and paint in the lightsaber. And this is very time intensive because you'd have to fiddle around. But with modern computers, you're able to actually track motion and other markers. In this case, it finds the lightsaber, you train it, and it's able to track it as it goes. So no longer do you have to follow around. Now, we can combine these together, such as the ground plane, the video feed, and an animation, to create something like Pokemon Go, which really is how it works. It tracks the ground plane to place the Pokemon in place, and then you're able to interact using your phone. We're going to make something a little bit simpler using markers so that you can play around with it. If you open a web browser and go to scienceday.github.io/AR-demo, you can go over and print your own marker cube. Now, what you'll want to do is print it out, then you'll want to cut it up, then you'll want to fold it, then you'll want to tape it. And this will leave you with a marker cube that we can use with the Science Day AR demo website. So go back to scienceday.github.io/AR demo. Go ahead and click on that second link. Tell it to allow your camera to be used by the website. Place your cube in front of it. And once you've done that, you'll see a render of Pikachu placed over the cube. This is using very similar technology and the concept of the cube over the beach, but instead of just sitting there, it's using the tracker technology that you would use on something like a lightsaber effect. Instead, it places the feed, the render of Pikachu on each face of the cube. So as you move your cube around, your video feed will display Pikachu from pretty much any angle you want. So please enjoy playing around with this AR and enjoy your Science Day.
Thank you so much for watching. Please follow us on social media to find more about our upcoming events.